Hi, everyone. Thanks for making it. I know by this time of the day, you've probably had too many ideas, too little coffee, too little food, and you're probably just wanting to get back and get to the bar or whatever. So I'll try and make this brief and as entertaining as I can. So I work for a company called Fjord, and we're a digital service design company, which has meant primarily designing screens for the last 15 years. And there's nothing wrong with designing screens, and I like screens as much as anyone else, but certain things have started happening in the last few years. Certain technologies have started maturing, becoming affordable, and people have started seeing ways in which they can combine them and start turning them into products and services that are implying a change in the way that we might be designing things in the future, designing interactive services in the future. And I, along with a few other people actually, came up with an idea called Zero UI, and it's kind of a contradiction. It's not, if you break it down, zero user interface, that's not actually what it means. What it means is moving away from the visual user interfaces that we've become so familiar with. And the first question you can ask is, why does it matter? Why do we want zero UI? What's the point of it? We're all very happy with our phones and our computer screens and so on. But actually, I think it is important. I think that we have become somewhat enslaved to our devices, enslaved to the screen. They're very seductive, they're tactile, they're visually gorgeous. We love them. We might even want to lick them sometimes, and because they kind of look like candy sometimes, especially some of the games. And that addiction to the screen has actually somewhat taken away something from our social interactions and even something from being human itself. The screen is a kind of a dual word. It has two meanings. One is a surface that displays something, and the other is a barrier between you and the rest of the world, screening. And if you look at the way people use their devices, they are often used as barriers, and they provide a kind of comfort, maybe a digital teat to suck on, to kind of protect us from social interactions, and you see this all the time. I was having dinner with my sister in London and her family, and the three kids spent the whole hour and a half just tapping away at their phones, which of course is completely normal now. We don't even, to remark upon it is unusual because it's so common. But really, we should think about that. And there are many things that we probably will always need screens for, but there's a whole load of things that we probably don't need screens for. And if we think about the way that we used to interact with phones, if you can remember way back, the Nokia and the Navi key and alphanumeric keypads, we actually interacted with them in a very different way. They didn't absorb your gaze so much. You could even use them without looking at them at all. Particularly if you're a 15-year-old girl, you can actually send entire text messages from inside your pocket, because our muscle memory is actually very powerful, and you can learn where the keys are and the buttons, and in a way then the technology becomes unobtrusive, and it becomes relegated to just a way of communicating, which is what you want to do, rather than being the center of attention. And we've just released a paper at Fjord about living services. And really, this is our interpretation of, I suppose, of the Internet of Things. We felt that term, clever though it is, it somehow seems to ignore human beings, because it's things, it's machines, it's devices talking to devices. And of course, there's an implication that humans are there somewhere in this orchestration. But for us, what the Internet of Things, what sensors, what connected devices, what they'll enable is to create services that seem to be alive, that have a life to them, that adapt to us and understand us in some way and can give us what we want without us having to put a lot of effort in. So we think this has come about because of two forces. The fact that everything's now digital, more or less, or will be soon, and our own expectations. And what do I mean by that? So as things become more and more digital, and as we have become more and more accustomed to things operating in this frictionless way, away from the messy and clumsy world of atoms, we expect them just to work, and to work instantaneously. And this is creating a kind of dissonance, because actually the real world doesn't work like that. The real world is bound by the laws of physics and space and time. That's physics, I guess. And it can't operate in this instantaneous, frictionless way that data and digital things can operate in. So you get annoyed when that Uber turns up 3 minutes later, when the time changes from 4 to 7, and you think, the software's gone wrong. But actually, no, it's not the software going wrong. There was a bit more traffic than had been up, than there was a minute before. So of course, so the physical world has to operate in these laws. So what is it? What is it that we can do to overcome that? I mean, there are certain clever things, and some very clever things, of course, that Uber do to circumvent this by modeling entire cities and understanding where you're likely to want to go, and they get it pretty accurate, 70% accuracy on knowing where you, as an individual, will want to go when you call that cab, based on your previous movements. So of course, by doing that, they can overcome the physical barriers by sending the cars to where they need to be. And likewise, with Amazon anticipatory shipping, they don't need you to order that PlayStation to put it on the truck. They know that 10,000 people in New York will order a PlayStation in December this year. So they ship them before anyone's ordered them. And that's how they can get the shipment to you in 2 days. So there are ways of overcoming this, but actually when we encounter these frictions, we actually get a bit disappointed, and especially younger people, they expect things to work instantaneously. I have a nice example of that later on. So we've come a long way in trying to overcome some of these physical things in the world, and this rather silly sketch, in a way, indicates something going on. So in quite a real way, machines have evolved, and Kevin Kelly wrote a wonderful book kind of finding all of these interesting comparisons between the way that man-made machines, man-made objects actually go through a process very similar to biological evolution of kind of natural selection of features. And I've thought about this quite a lot, that really when we started off, we were a long way away from computers. And over time, we've actually got closer to them. So what do I mean by that? I mean that they've become more intimate, they've become more personal, but also the way that we communicate with them has become much more natural. So, when we look at the first computer, or one of the first computers. There were computers before this. This was actually the first programmable machine, the Jacquard loom. When we look at that input device, input language rather, it's not very easy to understand. Likewise, that's not very easy to understand either. And so for a long time, we had to communicate with computers in a way that they wanted, not in the way that we wanted, and then of course that doesn't make it very easy or natural, and isn't very open to people. And then of course Douglas Engelbart had this seemingly epochal moment of realizing that actually to communicate with computers in an egalitarian, open way, that we had to create metaphors that were similar to the way that we wanted to communicate with each other through pictures and movement and through writing and motion and these sorts of things. And we kind of created this idea that computers were going to save us You know that, and there's a great documentary. I strongly recommend it. Adam Curtis, one of his many fantastic documentaries, All Watched Over by Machines of Loving Grace, and he posits the theory that we got rather seduced by the idea that machines were going to free us, whereas in fact they enslaved us by creating a very simplistic model of reality, because actually they couldn't. One, they couldn't sense enough data, and secondly, they couldn't process enough data. So the early cyberneticists had to make gross simplifications of what the natural world was like and what the political world was like, and so it led to some really bad decisions and very wrong ideas about what the world was really like. But it's possible that this early misstep, it was actually very, very important mistake to make, but it led to something much better. And maybe now, with the vast amount of data that we can capture about the world and the vast amount of processing we can do and the vast amount of sensors that are out there, we can actually build a much, much better model of reality, which will give us this power, which will free us. And there are a bunch of things that are out there that are kind of early experiments, early technologies that will enable this. And I've categorized them into a few different types. So the first is sensory augmentation, and that's a haptic cane, a force feedback cane for blind people, which essentially it uses vibrations to tell you what a room looks like or feels like. So someone who's blind can actually go into a room they've never been in before and walk across it completely confidently. The cane will tell them where tables and chairs are. So that kind of vibrational sensory effect on the body is going to be really interesting. And we've done some experiments with it, which I'll show later. Facial recognition, also very useful. So these Japanese vending machines, which have hundreds and hundreds of products in them, and actually they realized that to navigate through maybe 300 different items is not a very smart UI. So what they do is they look at the person using the machine and they try and interpret or guess what that person will order. So in this case, the schoolgirl will order the green tea, because maybe 70% of the time people who look like that will order green tea. Now, the problem with that is it creates a bit of a feedback loop, that once you have a few people ordering the same thing, then maybe that's the limited choice that gets offered to the user. It's a bit like the filter bubble that's been written about, like a physical version of it. But I think there's some interesting ideas here that actually can eradicate quite a lot of annoyance we might see in interfaces, particularly when we're trying to choose things. Then there's, artificial intelligence, the exobrain. And that's a favorite XKCD cartoon of mine. And we all know that feeling, that the feeling that it, in a way, is a bit of a shame that we now never know, we now don't not know things anymore. So you're never in this blissful state of ignorance. You just look it up on Wikipedia. Immersive displays, and although there have been some misfires in glasses over recently, which I think is not so much a technological problem as a problem of finding a use for it, and also some of the social problems with making people wear something so obvious. Now, Samsung and others are working on these contact lens displays. One of the issues, well, amongst many, one of the issues there is how do you power these things? And I think there's a way to go to actually get the technology working well, but we can easily imagine a point where we have these kind of heads-up displays and very unobtrusively integrated with our bodies. And then another one that's gaining traction, and we're seeing a lot of development in this in the last 12 months, is thought control. And that's the two guys from Washington University, Rajesh Rao and Andreas Stocco. And they did this fascinating experiment. I'm sure some of you have seen this, where just using some very simple equipment, an ECG, and linking the two headsets together using Skype, in fact, the guy on the left, Rajesh, could actually make the guy on the right move his finger just by thinking about it. So that sounds kind of worrying. If you could actually like drive someone like that. But apparently what Stocko said is that it felt like a twitch, and he felt like he kind of wanted to move his finger. He didn't have to. So that's a relief. We're not going to be mind-controlled zombies anytime soon. And of course, this is a very primitive thing that you're trying to do, move your finger, press a button, to get to the point where you can communicate more complex ideas to each other. I think we're quite a way away from that. And here's an interesting example of that instantaneous desire for reward. So what McDonald's did some research about 4 or 5 years ago, and they discovered that and this is the digital natives, this is the digital native problem I referred to earlier. They discovered that 18-year-olds, that they didn't understand why McDonald's called themselves a fast food restaurant, because it took 30 seconds to get your hamburger. That's not 30 seconds isn't fast. They're comparing it to how long it takes a web page to load. So we've got a real problem there. We've got a real physical problem. There's only there's a limit to how fast you can cook a hamburger, basically. So what they tried to do, what they did in an experimental drive-in system that they set up, was they tried to analyze the cars that were coming up before they got to the order point. They were analyzing the car shape and the model and mapping that to what people would order. And what they found, rather horrifyingly, I think, is that they could predict with 80% accuracy what you were going to order based on what car you drove. So I don't know what that says about human beings, but it's very interesting. And so if you're driving an SUV, you're not ordering a salad, I think, is the conclusion. So before you'd even ordered, they would start cooking it for you, and that's an interesting way that you can use the digital technology to overcome a problem, a physical problem. We're seeing this kind of thing appearing. I've called it skin-top computing because it's got a nice ring to it. But these tattooable circuits or transferable circuits that are very flexible. They don't hurt when you put them on, and they'll be able to do lots of interesting things, as well as the obvious stuff such as monitoring your blood pressure and skin temperature and moisture and things like that. They'll actually be quite useful for interacting, for kind of movement sensing without needing a leap motion device. It'll just know where you are in space. And they'll also be quite good for medical uses, for rehabilitation and diagnostics. So I think if we put all of these things together, sensors, immersive displays, learning systems, gesture control, etc., we might end up with magic, or something that was rather more elegantly described as enchanted machines. Dave, I can't remember his surname. Sorry about that. Sorry. Dave Rose has written a wonderful book about that. So I'm very pro that. I think that actually, we all know that Arthur C. Clarke quote that any technology sufficiently advanced will seem like magic. But I think that this magical potential is really interesting because we don't really want to interact with devices. We want to get out of them the content and the communication and the utility. The actual interaction with them is not the interesting bit. So if you can remove that or minimize it as much as possible, it could be quite a magical experience. And from a design perspective, this was a quote from David Kester, who was the former CEO of the Design Council in the UK. And he talks about design, and he really talks about it from a service design perspective, as far as I can see. And how an integrated approach using insights, so research, will guide business strategy. I think that's a very poignant thing to think about, to shape products and services, enabling innovation, based on an advanced understanding of user and market requirements. And I think that's a really great quote to take to your clients and put in front of them. But I think if we think about what we can add to that, if we add so as well as market requirements, we're we're adding computational systems that monitor, anticipate, and adapt based on human desire, then I think we have a very interesting kind of mission, really, for how to design new things. And I really like this model that B.J. Fogg came up with in his Persuasive Technology book, that actually design is about minimizing the cost of things. And he breaks it down into these 6 different categories: time, money, physical effort, brain cycles, social deviance, and non-routine. And I think most of these are fairly obvious, why good design can minimize the cost. And actually what he states, and this is really interesting, is that these are not constant, and these are not consistent between individuals. So an individual may value something more than something else. So obviously, if we think about time and money, that's a really clear one that's we see time and time again, that if you don't have much time but you've got money, you're willing to pay that bit more to get it quicker. That's a fundamental of the free market, it seems. But all these other ones are also kind of, you can play them off against each other. The amount of physical effort that something takes, that maybe you put more effort in, it's cheap, it won't cost you as much, and so on. We can see analogies for all of these. But the one that really strikes me as being needs a bit of unpacking is the 5th one down, social deviance. How does that play into design? And if you think about it, it's actually pretty clear, because if we didn't care about what people thought about us, we would do things in a much easier way. If you didn't care about being embarrassed in the street, you wouldn't necessarily get dressed in the morning. You'd just walk out of the house. But of course you do care, so then you have to go through the effort of having a shower and putting clothes on. And actually, an interesting kind of a design example of that is people who wore Google Glass were regarded as socially deviant by the majority. It was probably more of a kind of mobbing type of effect, you could say, that they were regarded as targets for vitriol. But actually, they were perceived as doing something that was socially deviant, and that made it very, very costly to wear them. So if we think about it, we need to really be very careful around social deviance. If we make people do things that are going to make them look strange or unusual, there will be a huge cost to it. So a lot of these ways of making technology move backstage, move into the background, fade away into the background, are ways of minimizing a lot of these costs. So what we used to do at Fjord until quite recently, maybe a year ago, is we're not generally technologists. We're designers who can think about future scenarios. And one of the things we did a lot of was create design fictions. And I believe that's a term that Bruce Sterling popularized. And really, what a design fiction is a thought experiment that allows you to apply a technology or a design idea to a context and see how users might behave in it and what some of the outcomes might be. And we do this a lot at Fjord. And an example that I particularly like, not from Fjord, is Naomi Kinsner's design fiction. She's actually a PhD student in the University of Jerusalem. And she came up with this really disgusting idea of using your body to power devices, but in a very visceral way. So here, your blood is actually powering these small devices. It's a very interesting thought experiment, because actually how you power these wearables, or maybe embeddables, we could call them, is going to be quite a big problem. And maybe you can use body heat, maybe you can use piezo, or motion or something, but in her example, and she actually is wearing, they really do actually, they're entering her body, and the blood, as it flows, kind of takes a detour and goes through the device and turns a little motor in it. So, interesting, provocative idea. And I guess the reason she's doing that is to make us think about what kind of technology we're willing to put in our bodies, and what the limits are to how we want to interact with machines. And so some of the design fictions we've come up with recently, here was an idea that pulls in quite a lot of different sciences and technologies. The idea that you might have something embedded in your body, and in this case, it's some kind of sensor inside your mouth, possibly one inside your brain, that monitors how much you like that cup of coffee you're drinking. So what it's doing is it's measuring the release of certain chemicals and hormones in your brain and your body. It's measuring your heart rate and your blood pressure and so on. So it's building up this very rich picture of how much you actually like that cup of coffee. Because actually, it's quite hard to judge. But if you can, one cup to another, if there's a tiny variation in how long it was left in the French press for, or so on. But using some kind of sensor, we could actually get a very accurate reading on how much actual pleasure it gave you, uninhibited by any kind of contextual stimulus that might be affecting the reading. So sending back that information straight back to the factory, where they create building up a picture over time of which one is your favorite blend. It will create that particular strength and taste of coffee for you and send it straight back to you. So a wonderful feedback loop. Now, of course, there's a lot of kind of objectionable moral issues here, and the idea that that later on you'd go to the bus stop and it would actually play the coffee that you'd so liked and send the aroma to you and then try and sell it to you straight away. So there's a lot of moral objections that we could have to something like that. And another one that we thought about, and actually has led to some tinkering that we're doing right now in the other hall, is having some kind of navigation device on your wrist, but also trying to think of it from a service point of view. So yes, navigation is fine, and it'll get you so far, but trying to think of how you could build a service around it. And this idea of the frictionless experience really led us to this idea that if everything could be as easy as getting out of an Uber cab, that would be wonderful. But that's actually quite hard to orchestrate. If you're driving your own car, if you're on the bike, if you're getting a train, if you're taking a flight, how do you combine all of that in some kind of fluid experience where you could effectively just jump on the plane? So the idea here is that you've got a sensor that knows how fast you're traveling at any particular point. It knows where you're going, and it's building up a score, a kind of environmental score, if you like, and that creates a cost over time for you. So all of your transport is all kind of combined. You don't have to pay for anything. You don't have to get a ticket. You don't have to swipe anything. It's literally just monitoring your movement, and by doing that, and of course, you need all of these companies to all work together and create a kind of a universal travel platform in a way. You can create this wonderfully frictionless experience where you just literally go and walk on a plane and fly somewhere, or you just get in a car and drive it, or you take the city bike, or whatever. And over time, it actually encourages you to be more environmentally friendly as well, because when you're riding the bike, you're actually gaining credit. When you're driving or when you're flying, you're losing a lot of credit. So that's an interesting way of thinking of it from a service point of view. So these are all just theoretical ideas, but we're actually bringing them to life in our make shop. Oh, the logo looks really big on there. It didn't look so big on my screen. Over the last year or so, we've actually started taking these theoretical ideas and putting them into practice. So we've actually set up our first make shop in our New York studio, and we're rolling them out across all our other studios. We've got a pop-up one here where we're trying to actually build something in real time. And what we're doing here is taking some of these ideas and putting them into practice, because actually one of the problems I think we're going to have with Zero UI is that we don't know what the interaction language is yet. If we think about haptics, if we think about vibration, we don't actually know what a certain type of vibration means. It's not obvious and it's not intuitive. And if we have to make people learn what a long buzz means versus a short one versus a staccato, then we've kind of lost already. We need to figure out what is the natural language of touch, of ambient sound, of all these different interactions that aren't visual. We need to figure out what they are. So we actually figured out a lot of different vibration types. We learnt quite early that it's not nice to have anything vibrating around your head. Actually, there's some. It can feel quite disturbing. So actually, there's some research that shows that we only really like being touched by a stranger, let's say, from about the elbow down to the hand. So any kind of touch elsewhere in our body can feel a bit strange, which is why we decided to use the neck, and actually we built this little lanyard, and you can see there on the phone we have all these different types of vibration that we can put into it. So the lanyard actually has two haptic devices either side on the neck, and we actually did a field test of it out in I think that's on 6th Avenue. So essentially it's vibrating on the left if you need to go left, it's vibrating on the right if you want to go right. If it doesn't